So what I want to start out with is sharing how to evaluate normality in a data set. And we're going to go to a very official sounding website here, statskingdom.com calculator. Of course, there are programs you guys can use that are maybe sound a little more rigorous, like SPSS and R and things like that, SAS. But there are also more and more of these free calculators online that are good and good for understanding when you're at an earlier stage, or if you just want to do it quickly, how you can evaluate, in this case, normality. So let's take a look at a data set I have here. This is in the shared Google Sheet that we've provided with you guys. If you click on in the bottom left, it's the t-test tab. And you'll see I've got this classroom full of excellent students here, Maggie through Taylor. And they've all done what we'll call a pre-test and received a score. And then they've done a post-test. And given that these are test scores, we might assume that they are normally distributed because test scores often are, but we want to verify that before we go any further and do a t-test. So what I'm going to do is I'm just going to highlight this, and I'm going to do on my PC, Control-C to copy that array. And I'm going to go back to this handy Stats Kingdom Shapiro-Wilkes calculator. Now, it says alpha level 0.05, so I'm good with that. It says name population. If you want to rename it, you can, but you don't have to. And then they've got some data here showing you all the different ways you can put it in. I'm just going to delete that and do Control-V, paste it in. And there's all the data. I click Calculate. And it actually doesn't specify too much, but there it is, sample size, and here are the answers. So it's showing right here, sample size is 15, the average is 76, the median, it gives you all of these descriptive statistics. Now, some of these things, you might not understand what they are, like skewness, and that is used to describe the shape of a normal curve. But you don't need to understand all of these things. It's not critical at this point. So the main thing you need to do for the Shapiro-Wilkes calculator, again, this is just named, you're going to get a lot of different names of like stats tonight, like Mann-Whitney and Kruskal-Wallis and Shapiro-Wilkes. These are just researchers and statisticians who came up with these formulas. So the p-value is 0.68. So it is above alpha, and we'll talk about how you interpret that. But before doing that, just at the bottom of this, there's some nice additional things they provide. One is the actual histogram of the data. And you can see that anytime there's more frequent values close to the median, like in this case, most values are between 70 and 80 or 80 and 90. And so you have a hump or sort of a hill, if you will. That is likely a normal distribution, even if it's not perfect, right? It's not that perfect bell curve, but it's still good enough. There's some other things here that you can look into and try and understand, but again, keep in mind the p-value, and it even walks you through. It says, since the p-value is greater than alpha, we accept the null hypothesis. And in this case, the null hypothesis is that it does not diverge from a normal distribution. So that is a double negative and a little confusing. That is understandable, all right? So let's go back here where I've actually put this in for you guys. Shapiro-Wilkes test of normality, if it's greater than 0.05, that means it is normal. It does not diverge from a normal distribution. Go ahead and use that data. Do a t-test. You are good to go. If it's less, that means it significantly diverges, okay? So, so that is a very quick way to use this website, because if you're in Google Sheets, it's a little bit harder to, Google Sheets does not have a Shapiro-Wilkes formula, right? So it does have some things where you can generate a normal distribution, you can do different things, but it doesn't have that.